Hello everybody. So in the last lecture, we have reached this slide. Okay, so we're talking about the PLC programming using ladder programming. So now we have reached the internal relays. So the internal relays are one of the elements included among the special built-in functions with PLCs. So they are used to hold data, that is bits, and behave like normal relays. So they are very similar to normal relays. So they do not exist as real-world switching devices, but the idea is that okay, we can use them as normal output and with input also relays. Okay, so they are very similar. The idea is that okay, they are battery backed. Okay, to ensure safe shutdown of a plant if we have a power failure. So the idea is that we can use them for um, to ensure that everything is switched off, etc. Even if we have power failure. And they can be treated in the same way as external relay output and input. So one PLC might have 100 or more internal relays. So an example of the internal relay, if we have an input 1 and input 2, input 3, okay, and then we have here an internal relay 1. The internal relay also is used as a switch to control another output. Okay, so also it can be used in this way, and this is typical for any relay. So here we have an output relay, okay, but the other one is an input relay. So they can be used for memory, for etc. So they are not used for switching an output, but they are used for memory. Yani if we make an as we are saying here. Okay, so here for example, if input 1 or input 3 are pressed and then input 2, okay, so we will switch this relay, we will hold the value until to activate, for example, another output with a certain with another input. يعني هون when we have a combination input 1 or 2 or 3, sorry, and 2 happens, we will save this state, and then if we press on the output input 4, we will get the output 1 will be actuated. So this is the idea. Here is another example. So here if we also for the Siemens notation, so the Siemens notation with the input addressing and the internal relay are represented by F, and the output relays are represented by Q, and with the addresses, etc. So this is the general notation to the left, and to the right we have the Siemens notation. So another use of internal relays is for resetting a latch circuit. Okay, so one of the application, if we have a latch circuit, so we can using input relays. So here if we press on this input, if we will have this input, the internal relay will be activated, and since here we have a normally closed one, so once this one is activated, this one will be open, and so it will stop the latching that is happening on output 1. Okay, so here this is the explanation. When input 2 is closed, the internal relay IR1 is energized, and so opens the IR1 contacts, which are normally closed, and the output 1 is switched off, and the output is unlatched. So we can, one of the options is to use it for latching. So latching is usually used as a memory to keep the state of a system, but once we are doing the internal relay, so can override this memory. So internal relay also are used for starting multiple outputs. So if we press on start and stop, so we use an internal relay. So here we are using an internal relay latching, if we want to say, and then if this one is activated, it will activate one output, another output, etc., a third output, depending on the configuration. So here we are using also the internal relays to start multiple outputs. So it latch to keep terminal relay 1 is energized when the start button is pressed. So once you press on the start button, as we have mentioned, the current will pass, since this one is normally closed, and then the internal relay will be energized. And since it's energized, this one, the switch connected to the internal relay, it will be on, and then the current will keep passing like that until pressing on stop. Okay, so the contact will be break from the start. So here we will not have a contact anymore, but we will have a contact in this direction. And the internal relay also, since it's activated, it will be activated here. So it will activate also output 1, and it will activate output 2 if input for output 2 is also on. And if it's not on, it will not be activated. And the same for output 3. So this is the idea. So the set instruction causes the relay to self-hold, and this is what's called, that is the latching or latch. So we can use the internal relays are as flip-flop. So for saying, okay, it can switch the state. Okay, so this is why in this slide we are using the term set and reset. So we can set and reset the system using internal relays. So the idea is that, okay, if we have two inputs here and we are controlling a block, so this block contains internal relays, so we can use it in the following way. So if we have the reset is a priority or the set is a priority, so we have two options. So if we start by having input 1 as on, so here we set input 1, okay, so the reset input 0 is the output, okay, and in this case if we set input 0 to 0, so we reset input 1, so there is no output. And if we set input 1 and we reset input 1, there is no output. And if we so the only output is when we set input 1 and reset input 0. So this is the input 1 and this is the input 0. So if we set this value, we will have an output, otherwise we will not have an output. So this is the idea of, so we can use them as memory. So if we set this one and the other one is 0, we will activate output 1. Then we can okay, so and then we can, all the other configuration will be 0. And if we do the opposite, so if we are doing the priority is for setting, so if we set input 1 and we reset input 0, there is an output. Okay, so since we are setting, if we set input 0 to input 0 and we reset input 1, so there is no output. And if we set input 1 and reset input 1, okay, so there is output. And this will be the case, yani whole two cases will give output, otherwise we don't have output. Yani we have outputs in two cases. Case when يعني هون input 1 input 2 in the address in 0 and 1. Okay, so if we set input 1 and input 2 is reset, it will be if we set, sorry, input 2, we will have an output. And if we set input 2 and also set input 1, will be an output. So in these two cases we have the output. Okay, so it depends really on the input 2. Okay, so this is the idea. So this input is used for setting and the other one is for resetting. So here if you look at this one, once we set the input to, okay, so the output is set automatically until the input 2 here is reset. Okay, but the output keeps settled. Okay, so once key, is kept set, okay, so the output is reset once we set the input 1. And input 1 has reset the output. On the other case, if input 1 is set on, so the output is not set, okay, until input 2 is set, and input 2 is for setting. So once it's set, the input 2 is set, okay, the output will be set until the input 1 is set input 2 is not set. يعني هون in this case input 2 will be switched off. يعني طالما is off لأنه ال priority is for set priority. So طالما ال input 2 is set, the output will be kept set. Once it's switched off, لأنه this one is 1, it will be turned off. Okay, so no priority for setting. Here is the opposite. So if we set input 1 and input 1 for setting, input 2 for resetting, if we set input 1, input 2 will be set until input 2 is reset. Okay, like here you say. Then if we set input 1 and we set input 2, once we set input 2, the output will be reset directly. لأنه this is a reset priority and not set priority. يعني the priority is for resetting. And once input 2 is, which is connected to the reset, is reset, this one will be automatically switched off. In the second one, it's the opposite. Okay, so we have two examples, so let's do them in the class. Okay, try to prepare them and we will discuss them in the class, okay, directly. This is just to test your knowledge. And in the we have also what is called the master control relay. So the master control relay is used when large numbers of outputs have to be controlled. So it's used to turn on or off whole sections of a ladder diagram. So it's abbreviated MCR. So if we want to turn sections, so this means that, okay, we have input 1 that control the master control relay, and once it's on, it will execute all this block. Okay, it will execute all this block. Okay, so this is the master control relay. And if it's off, it will stop running all this one. So this is important in terms of memory management. So if we have one input that will control most of the other values, so we can use the master control relay. One of the practical example for this one is the emergency button that is used in machines. So the emergency button usually is used to, it can switch on or off all the device. Okay, so it can switch it off if we have an accident. So we can use master control relay to control, for example, an emergency button or something like that. So the Siemens representation of the MCR is the following. So in this way, in the first one, this is the symbol to activate the master control relay, so master control relay area. And then we use the open MCR zone and clear the MCR zone. And here we have deactivate the master control relay. So what we are using, so this symbol is we have the MCR with a great symbol, okay, greater symbol. So this one will close the last opened MCR zone. So it will this one will open a master control relay zone. So here we open it with this symbol and we close it by this symbol with the opposite. Okay, we open it using this. Okay, so everything in between will be executed. And this one will activate the master control relay function, and the other one will deactivate it once we want to deactivate. And everything in between will be executed or not depending on the status of the master control relay. So this is an example. So if we have this one, here we activate, for example, the MCRA, and in the two we can open and close the one. Okay, so MCR zone will be this one, so we have open it and close it here. So this is the zone of MCR zone 2, and the zone 1, and we have used also this one, is the other one. So if we have two zones here, the first MCR which happened from in this zone, and the other on this zone, and we have these symbols, and inside we have output, and here we have another output. So if we activate the MCR, so we will have two zones to be activated, and then we can deactivate depending on the need. So this is an example similar, if you want to say, to what we had in the quiz about pneumatic systems. So we have a pneumatic system with a single solenoid controlled valves and involving two cylinders A and B with limit switches A minus, A plus, B minus, and B plus. So detecting the limits of the piston rod movements, give the sequence A plus, B plus, A minus, B minus, actuated using a start button. So we want to have this sequence, so we want to start A and then B and then retract A and then retract B using a start button. So this can be done, control of this element can be done using PLC. So this is an example of a PLC control. So here we have 4-2 solenoid valve in both cases, and we can control our elements. So here, using the start button, and we have the limit switch sensor, okay, that can be represented as switches. We have A plus, A minus, two limit switches, so to indicate the position here and here for a solenoid, and the position here and here for the other actuator. So B minus means that we are in this state. A plus means that we are in the end of the course, and the same for B. So here, if we start, we use the start push button, okay, and if limit switch is in the position B minus, okay, so here the solenoid, we will activate the solenoid to move forward, so we'll move forward this element. Or also if solenoid A is the first time, we need to press on start. Now if the solenoid A plus is on, so it will be kept on until we reach limit switch B plus. Okay, and here if we reach the limit switch B plus, if we reach the limit switch A plus, this one will keep moving until reaching A plus. This one will be kept activated, and it will stop here. Once we reach the limit switch A plus, the solenoid B plus will be actuated, and it will be kept actuated until reaching A minus. Okay, so here this is what will happen, and then once so first A plus will be activated until reaching the end. Okay, so we activate the solenoid to switch the state of the piston, and then when we reach, so it will keep going until reaching, okay, so it will be kept activated, and then once we reach this one, A plus, so solenoid B will be activated. So here we will move to this state, and this state means that B is actuated. It will move in this direction, okay, until reaching the end. Okay, so once we reach the end, B plus is activated, we will come here. So the contact will be separated here. Okay, so the contact will be breaking here on the solenoid A, and now the solenoid A, this one will not be on and this one will not be on. So the solenoid will get back to this initial position, and the A, which was in this position, will start retracting and going back to its position until reaching A minus. Okay, once we reach A minus, okay, here this one will be broken, and accordingly, since now we are not in A plus and we are not in this this condition is not anymore valid, so solenoid B will return to its initial value and valve on, and then B will start also retracting until reaching B minus. Once we reach B minus, okay, so we have terminated a complete cycle. So if we want to repeat the cycle, we can press on start again, and to repeat the cycle. We can also do it automatically, so we can change the element to be done automatically. So this is an example of how we can perform this sequence using PLC control. So in PLC also we have an instruction called the jump instructions, and this one enables part of a program to be jumped over, and this is very practical sometimes in a lot of application. So this means if some condition occurs in the program, then perform some instructions, else perform some other instruction, and like any if else condition in a normal programming language. But the idea, okay, if we have a certain input one here, we have a jump, so the jump can be represented similar to an output, so the program will jump to the end or to a certain value. يعني ممكن يكون هون we may have some instructions, other instruction to execute, but we will jump here, so we will pass all of these rungs, and accordingly this will not be executed. Okay, so it's similar to if condition, execute this one, otherwise don't execute him. Okay, so this is the condition, and here the jump, once we jump here, and we said that the program usually read from left to right and then top to bottom. Okay, so it will read the program, it will read the ranks in this way. So the jump will give the option to not execute these conditions. So in the term of the Siemens notation, so here we have the jump if input one. So once this one is activated, so the jump will be executed, and this is the end of the jump, or jump not. So this is the jump if not, and this is the end of the jump. Okay. So GMP, if you see GMP on the diagram using Siemens notation, so this means that jump if input is 1, and if you see GMPN, so this one is like the else, if you want to say. So jump if input is 0, and here dest is the end of the jump, and jump will jump to a destination, and this will be the destination in both cases. But the difference between these two is only the condition. Also, we have in PLC what we call the function boxes. So a function box is defined as being part of a program that is packaged. So it's used to package a certain program. So it's like function in normal programming. So here we have a block, okay, a box that contain a part of the program, and this part of the program can be used number of times in different parts of the same program. So it's the typical use of a function in programming. But here, since we are doing it in a graphical manner, so we have a function box. So each function box has input and output for connection to the main program, and is able to store values, and it contains a piece of program that runs every time the box is used. Okay, so PLC usual manufacturers supply a number of function boxes that can be used within programs. Some examples of the function boxes is the timer boxes. Okay, so here this is the timer on T on. Okay, and the other one is an add. Okay, so here, for example, if we have a Boolean enabling input, so if we enable the addition using, we can add inputs 1 and 2, and here we can give the output value. And we may have an output Boolean to say, okay, now the operation is done or something like that. And the timer is the same, so you can use a Boolean input to turn it on or off, and we have an input variable that represent the time that we want to take, etc. And here we will have the output. So we have the output variable that will return the timer and variable, and we have the Boolean output, for example, to give a certain indication about, for example, the timer is finished or something like that. Okay, so the timer are one of, as we mentioned, of the function boxes that are implemented inside the PLC. So PLC have timers as built-in devices, and the timers count seconds or fractions of seconds using the internal CPU clock. So a common approach is to consider timers to behave like relays with coils that when energized result in the closure or opening of contacts after some preset time. So this is the idea. And the timer is treated as an output for a ring. Okay, so with control being exercised over pairs of contacts elsewhere. So the idea is that, okay, we can set the timer and we can also preset the time required for the timer, and the timer can be used as a relay. So once we set, it will count the time, so we'll have some time delay by the timer before the activation of the element. And once this timer, for example, we can say, okay, after 3 seconds we will preset the time as 3 seconds, and once we activate the timer, so the timer is energized. So it's similar to any relay, but the idea is that instead of turning on instantaneously the input, we will turn it on after some timer. So after the preset time is finished. So it will give the output after the time is finished. It's finished. Okay, so there are a number of different forms of timers that can be found with PLCs. We have the on delay and the off delay. So on is on delay, so it's represented by T on or T dash 0, and T off is represented by off delay is represented by T off or 0 dash T. So the on delay, as the name indicates, will be on after a particular time delay. يعني it will turn on the output after some delay, while the off delay is on for a period of time before turning off. So it will be turned off after when the timer is finished. And we have the TP, the pulse, okay, timer, and this one is on for a fixed period of time, so it will give pulses. Okay, so the time duration for which a timer has been set is termed the preset time. This is what we call the preset time, and is set in multiples of the time base used. And usually it depends on what is the time base used, and we have some multiple. Some time bases are typically 10 milliseconds, 100 milliseconds, 1 second, 10 seconds, 100 seconds, etc. So if we set the value, for example, 5 here, the preset time, and the time base is 100 milliseconds, this means that the timer will be on or off depending on the application after 500 milliseconds. So we multiply simply the preset time with the time base to get the time. So this is important to look at, and especially when we are looking at the diagram, we give the preset time. So this is the preset time, usually is this one. So we give the 5, for example, to indicate the preset time. And then we have to look at the time base inside in order to know what is the value of the timer. Okay, so We have several number of different form of timers that can be found with PLC. We mentioned the on delay timer, the off delay timer, and the pulse timer. So each one has an input, a Boolean input to say, okay, start the execution, and has the time, the preset time. And he has an output Boolean, and also the output is time. So here, if we activate input 1, the Boolean, so the timer will start. So here we will start counting the time in the on delay, and the output will be executed once we reach the preset time. So if we said, okay, it's 500 milliseconds, after 500 milliseconds, so this one will be, the output will be activated. So this is the output. So the F delay is the opposite. So once we activate the input, the output will be activated automatically, and we will start counting the time, okay, and after the time is finished, okay, so we'll start counting the time after the input. Here the Boolean input is off. So here, from here, we will start counting the time. So once we reach the elapsed time, the timer output will be turned off. This is what's called the timer delay. And then we have the pulse timer. So the pulse timer, it has the same inputs, but the inputs are interpreted differently. So once we set the input here to 1, we will start counting time until reaching the last one, and here it will be turned off. No, this is, it will give a pulse, and this is the pulse time. Okay, and this is the idea. This is the difference between the timers. So the on delay timers in the Siemens notation are the following. So we have the set input, and we have TV is duration of time specification. So as the Boolean to say start, okay, the timer. And TV is the duration of time specification. R is the Boolean reset if you want to reset the timer. BI is the current value, time value in binary word, so we can get the current time value. BCD is current time value in the BCD word. And Q is the Boolean output indicating state of timer. So if it will, usually we connect Q to the output to be switched to be turned on once the timer is finished. So this is how it's represented. So the timer, as we mentioned, can be used as, and it can be represented as also the same as output, but the difference is since it's a timer, so we will have the delay. Okay, so here if we have, for example, input 1 is on, it will turn on output 1, and if output 1 is on, okay, so we will turn on the timer, and after the timer, if it's preset to 5.5 seconds, so we will turn output 2 after 5.5 seconds of the execution. So this is the idea. So first we turn output 1, and then we turn the output 2. So example of timers. So timers can be used to start 3 outputs, for example, such as 3 motors in sequence following a single start button being pressed. So this is an example. If we start, we press on the start. هلا أكيد هون الستوب is normally closed in order to operate. So if we press on start, so we will have the an internal relay on. And if the internal relay is kept on, so this one will be kept on. So if the internal relay now is on, so we will actuate timer on, the time T1 as T on. Okay, so it's the on delay. And here also we can control using the other timer T2, which is also a non-delay, so we can also execute it when IR1 is on. So now, once IR1 is on, we will start immediately motor 1. And if T1, so once the timer 1 is finished, okay, is terminated, so we will activate motor 2. And then after T2 is finished, we will activate motor 3. So in this case, we are performing this sequence, and okay, so this is what will happen once we click on start. We'll start motor 1, okay, and then after a certain timer, when the timer 1 is on, okay, we will keep until finishing timer 1 to start motor 2. يعني هون motor 2 will be turned after some delay, okay, due to the time. يعني when timer 1 the output is on, هون it will turn on motor 2, and when timer 2 is on, it will turn on motor 3, okay, and then we will stop. Once we press on the stop, we can stop our program. Everything will be returned to 0. So this is an example, and this one is in okay, so we can do it in this way, or we can represent it in this way with several internal relays. So we can say, okay, directly the timer is connected as a switch here, or also we can connect the output of the timer. And if it is and in practice it's done like that, but we can represent it in both ways. And how the timer is controlling an internal relay. So once the timer is finished, it will activate the internal relay. Another example is to cascade timers and having an on-off cycle timer. So here, for example, we have an input 1 and a timer 2 that is normally closed, and then we have the timer 1. Okay, so if it's set to 5 seconds with preset time, so after 5 seconds here, I want to click on the input 1. After 5 seconds, okay, T2 will be activated, and T1. Okay, so after 5 seconds, T1 will be activated, and once T1 is activated, so T2 will be. Then we have T2 will be activated after 5 seconds, and then we will control the output. Okay, the output, sorry, is controlled using T1. So the idea is that, okay, once we click on 1, T1 will be activated after 5 seconds, and this will activate the output. And then after some time, T2 will be activated. So as T2 is activated, this one will break the contact, so the timer will stop. Okay, so for 5 seconds, and then we can turn on the T1 for 5 seconds, and then etc., etc. So we'll keep doing this. So here we can cascade. An example is to flash a light on and off as long as there is some output occurring. Okay, so it can be done by cascading timers, and you can do it as an example, and we will discuss it in class also. So try to prepare it. Another example for using the timers is the traffic light sequencing. Okay, so in the traffic light sequencing, so we have the start. So once we start, we have state 0 where red is turned on only, and then we wait, for example, 2 minutes, and then we have the state 1 where red and amber will be turned on simultaneously, and we will wait 20 seconds, and then we will have the state 2 where the green will be turned on only for 2 minutes, for example, and then we have the amber only, okay, where we will it will be turned on 20. So first we'll turn on the red, then red and amber to say, okay, pay attention, you will start. Okay, we'll have the green, and then you have the green, and then the amber to give precaution to stop the motion. If you want to implement this graph set, so this is called the graph set. Okay, so if you want to implement this graph set that represent the logic inside the PLC, so we have the start, and the start will execute the red, and the red will be kept executed. Okay, so once the red is on, this one will be on, and the amber here can be executed by timer 3. Okay, so and here we have timer 1. Once red is activated, we have a timer red that will activate red and amber. Okay, so here First of all, we have the start. The start will execute the red. The red, this is the state 1. Okay. And state 1 also say if we turn on the amber after 20 seconds, we will turn on the red. Yani this one for this condition. Okay. And then we have the state 1 which mentioned that, okay, red 1, if red is activated. Okay, so we'll wait 2 minutes and then we will turn on red and amber. Okay, so we'll give the output to red and amber. And and now once amber is activated, okay, so we will have, we have passed this condition. The condition will not be executed لأنه قطعنا عنها. Okay, لأنه amber was initially off. So first we executed this one, okay, and number 1, and then we would jump to state 1. With state 1 we will turn on red and amber, and after this one is executed we will go here to have the amber, and now the amber is actuated, so we will turn on after 2 minutes. After 20 seconds we will turn on the green, and then once the green is on we will keep be on for 2 minutes, and then we will energize amber, and now we will go back and the cycle will start again. And once it's here, okay, so here we are at this state, so we have to keep the amber 20 seconds. So here we will go to this one, so we will turn it to red after 20 seconds, and the cycle will repeat. So this is how it's done. So another feature of the PLC is the counters, and the counters are provided as built-in elements in PLC. They allow the number of occurrence of input signal to be counted. So if we have an item that is passing on a conveyor, for example, we can use counters. So it can count items passing along a conveyor belt. We can count number of revolutions of a shaft using a sensor, and if we connect a sensor, we can count the number of revolution. We can count the number of people passing through a door, etc. of examples. So a counter is set to some preset value, and when this value of input pulse has been received, it will give an indication. Like the timer, but it's not a timer, it's a counter. So for example, we said, okay, we want to give a signal after 100% has passed from a door, okay, so or something like that. So once the value, the preset value will be reached, okay, so it will operate its contacts, and usually normally open contacts would be closed, normally closed will be opened, and this will allow us to take some action. For example, if we have some items that are passing on the conveyor, let's take, okay, we are using, for example, to package, let's say 15 juice bottles, okay, so once 15 bottle will be passed, okay, so this means, okay, now close, for example, the packaging and move the package elsewhere, so now the package is complete, so something like that. Okay, so usually a typical timer can count up to 16 binary bits of data, and by combining a timer with a counter, we can go to longer times can be counted. Yani, usually, since the timer can count up to 16 binary bits of data, and this has a limit on the value, okay, 16 binary bits, so this means 2 to the power 16, and 2 to the power 16 has some value, okay, to reach in terms of numbers. You can calculate it, and then if we want to go higher, then we are doing the execution for a longer times, okay, so we can combine a timer with the counter. So the counter will set, okay, this is the iteration 0, this is the iteration 1, etc. And we can go up to 216 and then beyond the 216 to the 416. And we have two types of counters. We have the down counters and the up counters. So the down counters count down from preset value to 0, so it will count in the opposite way. So the events are subtracted from the set value, and when the counter reaches 0, its contacts change state. And we have the up counters that will count in the normal way, so it will count from 0 up to preset value, and the events usually are added until the number reaches the preset value, and when the counter reaches the set value, its contacts change state. So this is the main idea. Okay, so for the counter we have a reset of the counter, and we have the counter down counter, this one, and this is one is the up counter, and we have the switches that are executed. So we can represent the counter in this way. We have the set of the counter, and we have the prescribed value, and we have the output that is controlled after the end, okay, in both ways, and it can be also reset for the counting when we are counting up, and here the same, we can reset. So example of the counter, okay, we have input 1 that is controlling a reset of the counter, okay, and here the input 2 is used for count up, and the counter will execute out. Okay, so here once we apply input 1, the counter will be reset. Okay, then when we press on input 1, okay, we'll start counting first time, second time, third time, fourth time, fifth time, etc., sixth time, etc., until reaching 10. And apparently we are using 10. Okay, so once we reach this value, the preset value, the output will be activated. Okay, and here this is the representation. So we connect input 1 to the reset and input 2 to the count up, and the prescribed value here will indicate, for example, it's the state of 10, and Q will give us the 1, will control the output. And this one, if we want to access the control value, for example, for debugging or something like that, we can access it from this value. Okay, so here, this is the example of counting items passing along a conveyor belt. So here we have the input pulses to say, okay, start the counting down. Here we have the reset count, the set counter, and the reset counter. And here we have the quantity that we need to specify, and the output will be executed when the counting is finished. And here we will stop the conveyor if everything is finished. This is the representation in the Siemens notation. So this is an example. Also try to prepare the example for the lecture, and we'll discuss it in the lecture. Okay, so try to prepare this example based on what we have speaking about. Okay, so let's stop here since the time of the lecture is almost done. So we will continue in the class or so the course, and then we will see you on Friday.